The next thing we're going to take a look at is the elasticity of demand. Now, the formula for the elasticity of demand is exactly the same as the formula for the elasticity of supply, only we're measuring this for a demand curve. There's one note that you need to be a little bit careful about. Now, recognize that demand is a negative relationship. When we have an increase in price, we see a decrease in quantity, or when we have a decrease in price, we see an increase in the quantity. So the sign you would get from applying the formula is negative. I need to point out a convention that economists usually just express elasticity of demand as an absolute value rather than a negative number. So please be careful and pay attention as you're going through to keep this straight. Remember that elasticity of demand represents a negative relationship, but a lot of times you'll see it expressed as a positive number. Along a straight line demand curve, unlike with the elasticity of supply, the elasticity will vary a great deal, and we'll show an example in a couple of slides here about exactly how that works and why that's important. Okay, so let's get to the calculations. When we want to calculate the elasticity, remember the basic formula is essentially the same. We look at the change in quantity from one point to another divided by the average of those two quantities in our midpoint formula to come up with the percentage change in quantity. And then we look at the change in price divided by the average price to come up with the percentage change in price when we apply our midpoint formula. So, for example, when we look at the elasticity of demand between A and B, the quantity goes from 5 to 8, which is an increase of 3, when the price fell from 6 to 5, which is a reduction of $1. So when we apply the formula, plug in 5 minus 8 divided by the average of 5 and 8, divided by 6 minus 5 over the average of 6 and 5, and we get the elasticity of demand between points A and B using the midpoint formula is minus 2.53. So essentially what this says is for every 1% increase in price, we get a 2.5% decrease in quantity demanded between points A and B. Now, between C and D, we apply the formula again. The quantity changes from 18 to 21 when the price falls from 2 to 1. So when we apply this through the formula, we get an elasticity of demand equal to minus 0.23. Now what you can see is that the elasticity between A and B was relatively high in absolute value. The elasticity between C and D was relatively low in value. You can think about this. Between A and B, going from 5 to 8 is a pretty substantial change in the quantity, but going from $6 to $5 is a relatively small change in price. Now, between C and D, the price falls by half, but the quantity only increases by a relatively small amount, just 3 units, the same 3 units that we had between A and B, but the percentage change in price is very large between C and D, and the percentage change in quantity is very small between C and D. And so we get a different elasticity when we evaluate this at different points along a demand curve. Okay. Now, why do we care? We care when we think about elasticity as we move down the demand curve. A firm's total revenue, the amount of money that a firm takes in, is given by price times quantity. So if we cut the price by 10% and 20% more customers come in to purchase, we'll see an increase in revenues. Revenues is this relationship between price and quantity. If we cut the price by some percentage and we get a higher percentage increase in customers, our revenues will grow. We'll have more money in the cash register at the end of the day. However, if we cut our price by 10% and only 5% more customers come in to purchase, we'll see our revenues fall. And obviously, a profit-maximizing firm is very concerned about how a change in prices will impact their revenues. So understanding elasticity of demand and understanding where you are on a demand curve is very important. Note that as you move along the demand curve from lower to higher quantities, the elasticities fall. And what this tells you is that past some point on the demand curve, cutting prices will reduce your total revenue.